Hello everyone. I hope you all are doing well. Today's topic is momentum and acceleration. Means the relation between momentum and acceleration. To understand the relation between momentum and acceleration, let's recall the Newton's second law. Because with the help of the statement of the Newton's second law, we are going to derive the relation between momentum and acceleration. Okay, I'm writing the statement of Newton's second law in the form of relation. So the statement of Newton's second law, it's right here, Newton second law. According to Newton's second law, the statement is rate of change of momentum is directly proportional to applied force. Applied force. Somewhere they mention external force, so that isn't just a force. So rate of change of momentum is directly proportional to applied force. This is the statement of Newton's second law. But when it comes to relation means talking about the equation. Okay, so let's convert these words into equations or in the form of symbols. Okay, the rate of change, it means, what do you mean by the word rate? The rate means it's like with respect to wherever the rate word is coming, it's like with respect to time. For example, rate of change of velocity, it means velocity over time. Rate of doing work is called power, it means work done over time. Okay, so rate of means with respect to time, change in momentum. I'm making the symbol of change in momentum, that is delta. Delta is, we are using this delta for the change. Although in maths we are using this as a triangle, but in physics this symbol we are using for the change. Okay, so rate of change of momentum is directly proportional to applied force. Okay, now let's open this equation. Then it will be like, change in momentum means what? Final momentum minus initial momentum. Like when we talk about the change in velocity, we say the word final velocity minus initial velocity. So change in momentum is final momentum minus initial momentum. So I'm writing like F and this initial over time. Okay, now let's write down the momentum, final and initial momentum in the form of symbols. So final momentum, what is the basic formula of momentum? That is P is equals to mass times velocity. This is the general formula of momentum. But this momentum, if you're writing for the final, you will write mv. But if you're writing for the initial momentum, then you can change the velocity as the initial velocity like this. Okay, so at the place of the final momentum, I'm writing mv. At the place of the initial momentum, I'm writing mu over time. Okay, there's a one thing which is looking common here, that m. Can we take m as common? Yes, because we have m here also, here also. So I'm taking m as common. So it will be v minus u over t. Okay. Now there's a one thing interesting here, that what is the formula of acceleration? The formula of acceleration is v minus u over t, right? So can we write at the place of v minus u over t as acceleration? Yes, we can write. So I'm writing here m a. At the place of the v minus u over t, I wrote here acceleration. Okay. Now you know the formula F is equals to ma. You know, in this the whole explanation, we are doing two things. One thing is we are understanding the relation between the momentum and acceleration. Another thing is we are deriving the formula of F is equals to ma. F is equals to mass times acceleration. Okay, now we are at the end of the derivation. Now, but this directly proportion is looking a little weird because in physics, all the formulas are in the form of equals to equals to. So why this directly proportion is? So how are you going to remove the directly proportion? Okay, there's one thing to understand here. Whenever the directly proportion comes in physics in any of the equations, when the directly proportion removes, you want to remove the directly proportion and put the equals to, then with equals to a constant always come, means directly proportion you are removing, at the place of directly proportion equals to and a symbol of any constant. Okay, but every equations have fixed constant. So in this equation, if I will remove the directly proportion and putting the equals to, then the fixed constant is k, the symbol is k. Okay, is equals to ma. Okay, but as the formula which we know or we are using in common is simply f is equals to ma. There is no k and all. But you know, in this derivation, the value of the k is 1. This is the experimental value which we can find in the laboratory. Okay. So k, the value of k is 1. So f is equals to, if you will substitute the value of k as 1, so the final is f is equals to ma. So this is the relation between the momentum and acceleration. Or at the end we can say that this derivation, through this derivation we see that momentum and acceleration are related through force. Momentum and accelerations are related through force, because the change in momentum leads to acceleration. Okay, if you're not getting these words, let's take a simple example. You are sitting somewhere watching the video, right? Your body is stationary, but once you start walking, there's a change in momentum. How this momentum changes? Because you applied the force, right? See the relation between these words there. When you are sitting, your momentum, your velocity is 0. It means your momentum is 0, right? Your momentum is 0, you are stationary, your acceleration is 0, you're not applying any force. But once your body comes in motion, now your velocity changes. It means acceleration changes. And if velocity is changing, it means the momentum is changing. And these change of acceleration, momentum is coming from where? Because you apply the force on your body. So how this force leads to acceleration, or the force leads to change in momentum. So this is the relation of force with accelerations and with momentum. So this is all about the relation between accelerations and momentum. I hope this explanation was clear and helpful. If you have any questions, feel free to ask in the comments below. And don't forget to like this video, share it with your friends, and subscribe to the channel for more physics lessons. Thank you for watching and see you in the next video. Thank you so much.